In this video, we are going to talk about the greatest common divisor. If we have two integers, a and b, the greatest common divisor, or GCD, is the integer that represents the largest divisor of both a and b. For example, suppose we let a equal 70, and we let b equal 35. If I want to find the greatest common divisor of a and b, I can see in this case that it would be 35, since 35 divides evenly into 70 as well as into itself. However, if I were not certain of what the GCD were, then I could use prime factorization to find it. If we break 70 down into a product of primes, we would have 7 times 10, where 7 is a prime number and 10 is composite. Therefore, we'll continue to break down 10, and that becomes 5 times 2. Next, we would take 35 and break that down into a product of primes. 35 can be broken down into 5 times 7. Next, I would look at the primes in each prime factorization and note the ones which were common to both factor trees. I see that they each share a 7 and they each share a 5. Therefore, the GCD of 70 and 35 is equal to 7 times 5, or 35. Here's another example. Suppose we have the numbers 42 and 27, and we wish to find the GCD. We'll start by setting up our factor trees. Here we have 6 times 7, where 7 is prime and 6 is composite. So then 6 can be broken down into 2 times 3. 27 can be broken down into 3 times 9. 9 is composite, so we can break that down into 3 times 3. Here I see that both factor trees share the prime number 3. Therefore, the GCD of 42 and 27 is equal to 3. And here's one more example. Suppose we have the numbers 54 and 63. Note that when you're asked to find the GCD, you may see notation such as that which we used above, where it says GCD, followed by parentheses, containing our two integers. Or it's also common to just see a set of parentheses with the two integers in it. Note that these are not considered an ordered pair. So to find our GCD of 54 and 63, we set up our prime factorization on each number. 54 can be broken down into 6 times 9, where both are composite, so we continue to break them down. 6 becomes 2 times 3, and 9 becomes 3 times 3. 63 can be broken down into 7 times 9, where 9 is composite. That's broken down into 3 times 3. In this case, I see that we have a 3 common to both, and another 3 common to both factor trees. And those are the only factors which 54 and 63 have in common. Therefore, the GCD of 54 and 63 is equal to 3 times 3, which is equal to 9. The last thing I'd like to mention is that any two integers will always have at least one common divisor. Those pairs of numbers which have only one common divisor are called relatively prime. Relatively prime integers have a GCD of 1. For example, the GCD of 2 and 3 is equal to 1, so those numbers are relatively prime. And the same can be said for 11 and 29. Their GCD is equal to 1, so those pairs are relatively prime. This concludes our example about the greatest common divisor. I hope you found it helpful, and we'll see you next time.